Alright, so for our notes today, we're going to start with systems. Okay. There are three kinds of systems that we need to talk about. We're going to talk about open, closed, and isolated systems. An open system, now all of these systems have a couple things in common and a couple things not in common. So an open system has exchange. If we look at the picture in our lesson, we have exchange of heat, and exchange of matter. So you might think about an open system as a glass. Okay, we have ice in the glass. And you can't see that. You have ice in the glass. What's going to happen to that ice after a while? It's going to melt. If there's liquid in it, what's going to happen to the liquid after a while? It's going to evaporate, right? So that means stuff, matter, can leave, and heat can be exchanged. Right? So a closed system, there is an exchange of heat, no matter. So what on earth does that mean? You might think about a closed system like a can of soda. Okay? Can of soda. So you might have condensation on the outside, but can the soda get out of the can? No. Can the water from the condensation go inside the can? No. But can the can change temperature? Yeah, if I throw those sodas in the refrigerator, they're going to get cold. If I take them out and leave them outside, they're going to get hot. So, closed system, the matter cannot get out. Nothing can escape. So we might write that. I mean, nothing is a problem word because heat can escape. But we're talking about measurable, like, matter, stuff. Okay? And then an isolated system, there is no exchange. Not heat, not matter. Okay? So you would think about that as like your thermos. And we'll label that because that's a terrible drawing. Okay? Nothing leaves. It's going to keep it the same temperature for a while. Okay? So what are some things that are in common with these systems? Boundaries are the limits of the system. So just like we have boundaries of the school building, okay, a school building might be a good example of an open system. Okay, we have kids coming and going, we have other things, we have food trucks coming and going, we have sports spectators coming and going. Okay, It's an open system. There's still boundaries. There's still walls. But things are coming and going. Right? A closed system might be more like, I don't want to say that one, but maybe more like a jail. People aren't coming and going, they're staying there. Okay? But other things, food is coming and going. But the people in there stay. And then an isolated system might be like a deserted island. Nobody's leaving and nothing's coming or going. Okay? So that kind of idea. There are surroundings for all of these things. Surroundings are everything outside. And then one last for the systems concept. The universe equals the system plus the surroundings. The universe equals the system plus the surroundings. So you might have a really big system, like a planet, the Earth system, and then everything outside of the Earth. You might have a really tiny system, like our pop can here, soda can. Thinking about the Earth, which one of these would the Earth be? Open, closed, or isolated? Why do you say open? Do we have an exchange of heat outside of our atmosphere? Absolutely. We have the sun coming in, and we are losing heat. Do we have an exchange of matter? Well, spaceships. We have had astronauts leave. We have asteroids come in. So we could consider Earth an open system. Okay, that's a pretty decent answer. All right, so thinking about systems, those are the basics definitions that you need when we discuss systems. Now, why on earth are we discussing systems? This exchange of heat, exchange of matter, is a big deal for thermochemistry, which is what we're getting ready to start discussing. Okay?